Okay, let's open up a new Colab notebook. Go to File, New Notebook in Drive, and we're going to call this one Strings. So strings in Python, or whatever you put in between single and double quotes, they're equivalent in Python. You often will give it a variable. Let's go with a great feeling. How about awesome? Really great word there. And let's check the type, the global function in Python, like the print, meaning it works with all different types of inputs. And we press Shift Enter. And we're expecting, as Colab is connecting, that this is going to show us it is a type string. str, that's what Python uses for string. Just to show you, if you wanted to put in like a number, like 2025, but you put it inside of quotes, what type do you think it is? Well, it should be a type string. We can check it, type number. Knowing the type is very important. If you wanted to convert it to an integer, you could put int in front of number because it's convertible. Okay, so you get now the int without the quotes, but if you check the type of number here, okay, hopefully you're following this. It still says string y because this delivered the integer, but you didn't save it. So if you wanted to save it as an integer, this is how you get something out of a string. And this is actually important because when you interact with users, like when you type in a keyboard, they're strings. So programmers have to actually compute them to integers as such. And so now if you reassign it and check the type, you can see that it is an int, and now you can perform mathematical operations on it. But let's go back to our string of feeling here up at the top. So what can you do with feeling? Well, it's a string, it's a certain type. And so if you do the dot, these are some of the methods that you can do with strings. For instance, I can capitalize it. Okay, a method means it's operating on feeling, so you want to give it a parentheses. Now, if you press Shift Enter, you can see it's been capitalized. What if you want it in all uppercase? Look, there's an upper. Just start typing. You can often get what you're looking for, and there you have it. What about all lower? This is the one I use the most. Dot lower. You can see it makes it all lower. And the reason why is because if you want to check, oh, does the word match? You don't want to bother if it's capital or not. You just want to put that in there. You want to like make it all lower so it's easier to check. So these are what you can do with strings. You can also use what's called an F string. I use these a lot. So let's say we want to make a sentence including the variable feeling in it. How can we combine them? Well, you can use an F string. So an F string would look like this. Write the letter F, then a quotation. Okay, now you're basically inside of an F string. You can see F changed color, right? I can say today is going, let's go with the future, to be, and then I put in inside of squiggly brackets my variable, okay? And everything else will be the same. Okay, so here's my F string. Let's say I want to store this. I can store it as a sentence, perhaps. And now if I print out that sentence, let's see what we get. Today is going to be awesome, a nice, clean looking sentence. If you do it without print and press Shift Enter, you can see it's the same, but it does show you the quotation mark. So it's showing you what it's stored as. Here's a program, whereas print is designed for display. Okay, F strings are really great. It allows you to do things like the following. If you have the radius of a circle, let's say it's 3, and then you want to add, say, a suffix like pi, you can like show what the area is. Well, the area is what? Well, let's use an F string, okay? Let's use, it's the radius squared. Now to start the F string, you need the quotes. Then you put the curly brackets in, so you get radius squared, and then just with the suffix next to it. Okay, and that's another variable here, so I would put suffix. And now if I print out the area, you can see you get 9 pi. Okay, so very nice. And note that that gives you the exact area of the circle instead of the decimal representation, which even though sometimes it looks like it has more precision because there are more decimal places, note that that is just, an estimate, and that when you include pi, right, you're giving the precise answer. It's assumed that, hey, we're including an infinite number of decimal places here.